Welcome to the session of the differential equation. In this session, we will discuss equation to reducible separable form part 2. In this session, we already discussed about how we can solve a differential equation even though if it is not separable. By substitution, how can we make that differential equation into separable differential equation, how then solve? That we discussed just before. So, we can substitute any part of the differential equation, we just take any part of the differential equation and after that we make them into separable equation. We know about the separable equation, we have the separable equation is of if a differential equation of the form of some g of y dy is equal to some f of x into dx is there. If we separated the differential equation like this, now we are able to integrate both sides. While integrating both sides, we can make this as integral of g of y dy is equal to integral of f of x dx is there plus c, the arbitrary constant c is there. While integrating this, we can solve this differential equation. So, this is a very nice method of solving first order differential equation. See, while solving a differential equation to separable method, that we can use this form for solving separable method. But as I said you just before, there may be some differential equation that is not separable, but we can make that is into separable by giving some substitutions to differential equation. So, say the question, solve the differential equation, the ordinary differential equation, solve the ordinary differential equation 2x square y dy by dx, 2x square y dy by dx is equal to tan of x square y square is equal to tan of x square y square minus 2xy square minus 2xy square. Okay. This is the differential equation 1. So, while evaluating this differential equation, by seeing itself, we understood it is that it is too difficult to separate the variables. Okay. So, our aim, how can we separate this by substitution? See, I would like to just take this rewrite this as the differential equation as this is equal to I took minus 2xy square from RHS to LHS. So, we can rewrite this equation as 2x square y dy by dx minus 2xy square is equal to tan of x square y square. So, would like to put this as equation number 2. Okay, fine, even though this is not separated. So, our thought, how can we separate it, for which we can give a substitution. So, inside the tan we have the x square y square is there. So, we just put u as x square y square. So, we put u is equal to x square y square. Okay, fine, we can we can check by giving this substitution, have we able to separate this equation, have we able to convert this differential equation as a variable separable form. So, we would like to differentiate this is du by dx is equal to this is the first function is there, x square is the first function and y square is the second function. Therefore, du by dx is equal to x square into derivative of the y square, that is 2y into dy by dx plus now we can have this is here we have this is a y square into derivative of x, that is 2x. So, actually see this is y square dy by dx du by dx equal to 2 x square y dy by dx this is equal to du by dx is equal to that is du by dx is equal to du by dx is equal to 2x square y dy by dx, 2x square y dy by dx, 2x square y dy by dx plus 2y square x plus 2y square x. Okay, fine. Now, just see the differential equation 2. In differential equation we have 2x square y dy by dx minus 2xy square, this is equal to minus 2, sorry, while taking this minus 2xy square to here, this is the plus 2xy square is there. Therefore, plus 2xy square. So, that the same is came here 2x square y dy by dx, 2x square y dy by dx plus 2xy square plus 2xy square, that is 2xy square, 2y square x, we can write this as 2xy square. This is equal to 2xy square. Okay, fine. Therefore, du by dx changed like this. Fine. Therefore, we can write this as, instead of this we can write du by dx. Therefore, from 2 we have du divided by dx is equal to, the left side is completely du by dx, therefore, tan x square y square is u, tan u. Fine. Therefore, this is equal to tan u. Fine. Du by dx is equal to tan u. This is equal to du divided by tan u is equal to some dx is there. So, instead of tan u we can write that as a cot u, okay, 1 by tan u. So, we have 1 by tan u is cot u du is equal to dx is there. Now, separated. See, the left hand side is a function completely containing the variable only u. The right hand side is a function just containing x only dx. So, we can integrate both sides, sorry, integrating both sides, integrating both sides. So, integrating both sides we have integral of cot u du is equal to integral of dx, integral of cot u du is equal to integral of dx plus c, integral of dx plus c. So, okay, fine. So, integral of cot u du is there, we have log sin u, log mod sin u is equal to integral of dx is x plus c. So, log sin u is equal to x plus c. See, come back to u is equal to x square y square. So, instead of sin u we can replace u as x square y square. Therefore, this is equal to log sin of x square y square is equal to x plus c. Fine. Therefore, we can write this as log, we can apply exponential function on both sides. This is itself an answer. See, this itself we can consider as a general solution. Maybe we can reduce again. So, we can write apply exponential function, Therefore, we will have e raised to log of sin of x square. So, e raised to log of sin of x square y square, sin of x square y square is equal to e raised to x plus c, Therefore, this is equal to e and log is there. Therefore, that will go on. Finally, we will have sin of x square y square is equal to e raised to x plus c, that is e raised to c into some e raised to x is there. Okay, fine. Therefore, we can write this as sine of x square y square is equal to some e raised to c. I would like to put this as c1 e raised to x, where c1 equal to e raised to c, where c1 equal to e raised to c, sine of x square y square. Okay, fine. I would like to take this sine to opposite side, therefore, this may be sine inverse. X square y square is equal to sine inverse of c1 e raised sine inverse of c1 e raised to x is there. Okay, fine. So, therefore, y square is equal to 1 by x square into sine inverse of c1 e raised to x. Okay, fine. So, this is the final solution. Maybe you can write this if also we can write this as y is equal to 1 by x into square root of sine inverse of c1 e raised to x. This may be the solution. Maybe we can write like that also, that is y is equal to 1 by x into square root of sine inverse of c1 e raised to x, c1 e raised to x. Okay, fine, is the general solution. Now, need to take these all parts, this is enough as part of the solution. See what we did here, my dear students, actually our aim is to solve this differential equation, but while seeing this differential equation, we understood it is that it is a little bit tedious, complicated form, and very tedious to convert that as a separable form. So, we can give a substitution for x square y square from this equation. This is the highest powered form, and we understood while evaluating by imagination itself, we can understood that while differentiating these parts, we are able to get this one. So, that we put u is equal to x square y square. So, we put x square u is equal to x square y square is there, we can differentiate du by dx, we can differentiate by taking x square as a first function and y square as a second function. So, that we are okay, we can found du by dx as a 2x square y dy by dx plus 2x y square. So, while going back to equation 2, we found that the LHS stands for du by dx. So, we replaced LHS as entirely du by dx, and the RHS is the tan of x square y square. The x square y square is equal to u, therefore, tan u is there. See, fine. Now, we can separate du by tan u is equal to dx. Now, we separated the left hand side is completely contain the terms of u only, and the right hand side completely containing terms of x only. So, that we can have 1 by tan u, we can write as cot u du is equal to dx. We can integrate. So, while integrating both sides, we will have integral of cot u. Integral of cot u is equal to integral of dx plus c. Integral of cot u is log sin u, and log sin u is equal to log of sin of x square by replacing u is equal to x square y square, by replacing u is equal to x square y square. So, we found log of sin of x square y square is equal to x plus c. Fine, this is enough, but while applying exponential function, we will get a nice form of this solution. So, we will have while applying exponential function, it is reduced to sin of x square y square equal to e raised to c into e raised to x. E raised to c can be write as c1. Therefore, sin of x square y square is equal to c1 e raised to x. while taking sine to RHS, we will have x square y square equal to sine inverse of c1 e raised to x. Now, y square is equal to 1 by x square into sine inverse of c1 e raised to x. Maybe by taking square root, we are able to found another form. Okay, fine. We just move to another question. In the next question is a initial value problem. Solve the initial value problem. Solve the initial value problem. Solve the initial value problem. dy by dx is equal to y minus x divided by y minus x minus 1, y minus x minus 1. Y of minus 5 is equal to minus 5. Y of minus 5 is equal to minus 5. Fine. See, this is the initial value problem. We have initial conditions that are there. Here we have the value of x naught. The value of x naught is minus 5 and value of y naught is also minus 5. Okay. While seeing, I would like to put this as equation number 1. See, while seeing the equation, we can evaluate the equation. By the evaluation, we understood it is that this is not separable, because y minus x is there in numerator and y minus x is there in denominator. So, we are unable to separate. So, the only option is to separate by substitution maybe. So, we have a very best choice for the substitution. Our best choice for the substitution is maybe y minus x. Okay, y minus x is our best choice for the substitution. So, put u is equal to, we put u is equal to y minus x. Okay, if we put u is equal to y minus x, no problem, we can differentiate. So, differentiate. Differentiate both sides with respect to x. With respect to x. So, fine, differentiate both sides with respect to x. Now, we can differentiate, that is the u dash or du by dx is equal to y is there. While differentiating y, we have just dy by dx and dy by dx minus 1 is there. Okay, fine. From here we have the value dy by dx, du by dx plus 1 equal to dy by dx. Therefore, dy by dx is equal to dy by dx is equal to du divided by dx, du divided by dx. While taking minus 1 to here, plus 1 will be there. So, du by dx plus 1. Okay, fine. Now, we found we have the apply in equation 1. So, dy by dx, instead of dy by dx, we have du by dx plus 1. So, this is equal to, fine, just a minute. Okay, so dy by dx is equal to du divided by dx plus 1. Okay, fine. Now, y minus x divided by y minus x minus 1. Y minus x is u. Therefore, u divided by u minus 1. Okay, fine. U divided by u minus 1. Fine. Okay, we can take this is to this one to here. Therefore, du divided by dx is equal to u divided by u minus 1 minus 1 is there. Fine, we can take this is to here. Therefore, we have du divided by dx, du divided by dx is equal to u minus u minus minus 1 plus 1 divided by u minus 1. Okay, fine. This is u and minus u will cancel. Therefore, we will have du by dx. We will have du by dx. We will have du divided by dx. Du divided by dx is equal to 1 divided by u minus 1. 1 divided by u minus 1 is there. Du by dx is equal to 1 divided by u minus 1. So, we can separate the variables. Now, we are able to separate the variables. So, we can take this is to here and dx to here. So, we will have u minus 1 du is equal to some dx is equal to some dx. See, my dear students, this is u minus 1 du. Now, the separated form is there. Now, variables are separated. As we done in variable separable method, it is easy to solve this equation by integrating both sides. So, integrating both sides. Integrating both sides. Integrating both sides. So, we have the integral of u minus 1 du, u minus 1 du is equal to integral of dx. Okay. So, we can write this as u minus 1 du as this the while integrating this is we have u integral of u, that is u square by 2 minus u is equal to integral of dx is x plus the constant of integration c is there. Okay, fine, u square by 2. Now, this is the solution in u and x. Is a solution in u and x. So, have to replace the value of u. Okay, we put u as y minus x. Okay, replace u by y minus x. So, we just replace u by y minus x. So, what will happen while replacing u by y minus x? Instead of u square, y minus x whole square. So, this is the y minus x whole square divided by 2 and then minus of this is minus u is there, we will replace u by y minus x, minus of y minus x is equal to the opposite side is nothing, that is the x, sorry, the opposite side is nothing, that is the x plus c, where c is the arbitrary constant. Therefore, this is the x plus c. Fine, we found a general solution. So, this is the general solution. We can stop here. Is the general solution, is the general solution of, sorry, general solution of given differential equation, general solution of given differential equation is the general solution of given differential equation. Fine, okay, but our solution is this one initial value. Our problem is initial value problem. As because initial value problem, we have initial condition, we have initial conditions y of minus 5 is equal to minus 5. That is the meaning, it is that when x is equal to minus 5, then y is equal to minus 5. Okay. So, we replace that is in equation number, I put this is the equation number 3. Okay. Put in 3. Put in 3, put in equation number 3. See what will happen, instead of y we have minus 5, instead of x we have minus 5 is there. So, we have y minus x whole square minus 5 minus minus 5, that is minus 5 plus 5 whole square is there. Okay, am I right? Minus 5 minus minus 5 is there, okay, whole square divided by 2. Okay, then next one is minus y minus x is there, that is the this is equal to plus minus 5 minus y minus x minus minus 5 plus 5 is equal to some x plus c, instead of x this is the value minus 5 is there plus c. Okay. See, minus 5 minus plus 5 is 0 and this is also 0, therefore, that the entire part is 0, no problem. So, we take c is equal to c, that is c minus 5 equal to 0, therefore, c is equal to plus 5. Now, we found the value of c as 5. Okay. So, c is equal to 5, therefore, the particular solution, of differential equation is, that is y minus x whole square divided by 2, y minus x whole square divided by 2, y minus x whole square divided by 2 minus of y minus x minus y plus x is equal to x plus c, c as a 5, x plus 5. And here we have minus y minus x is plus x, and here also we have one more x is there. So, we can cancel this x and x, we can cancel, therefore, y minus x whole square minus y is equal to 5. So, we can have this is equal to y minus x whole square minus 2 into y minus 2y whole divided by 2 is equal to 5. Therefore, we can take this is to here. So, we found this is equal to y minus x whole square minus 2y is equal to 10. Now, finally, we arrived the general solution is a particular solution. So, is the solution of the equation 1, is the particular solution of given initial value problem, is the particular solution of given initial value problem. See, here also we did as we done before, while solving this we just substituted y minus x as x, just differentiate the substituted part and we replace the values, we found value for dy by dx, we apply in the given differential equation. So, we found we separated the variables, while separating the variables we found as u minus 1 into du is equal to dx. While integrating both sides, we will have the solution, general solution in x and u. We replace u by y minus x. So, we have the equation 3 both that is an equation in y and x. So, as because this is a initial value problem, we apply the initial condition, that is x is equal to minus y is equal to minus 5 when x is equal to minus 5. So, while applying the initial condition, we found the value of c as 5. We just apply in 3, by the manipulating this we found the general solution. So, this is the method to also this both the questions we discussed how we can make a differential equation even though that is not a separable differential equation. How can we convert that equation into separable differential equation by substitution, that we discussed in all these questions. So, I think you understood very well on this substitution method. So, I am providing you some assignment questions to be more clear this question. Solve the differential equation dy by dx is equal to y by x into log of y by x plus 1, log of y by x plus 1. Okay. While seeing this differential equation, we understood it is there because log of y by x plus 1 is there, therefore, unable to separate now, but can be separate by giving substitution to y by x. Okay. Solve the initial value problem. solve the initial value problem. Solve the initial value problem. 2x square y dy by dx, 2x square y dy by dx, 2x square y dy by dx is equal to tan of x square y square is equal to tan of x square y square, tan of x square y square minus 2xy square, minus 2x square y square, where y of 1 is equal to y of 1 is equal to root of pi by 2, square root of pi by 2. See, we already discussed the how to solve, how to make this question into variable separable method, and just apply the initial conditions. While applying the initial condition, you will have the initial value problems. There are many questions available in the literature of the differential equation to solve the substitution method. You may do all that things that will be clear you the concept of the substitution method. Okay, thank you for watching this videos. Continue watching. Thank you very much.